So when we look at this, we see that the 12 is across from the 90 in a 45, 45, 90 triangle. Now, we've seen these often enough that by now I'm hoping that y'all know that this is 6 root 2 and 6 root 2. That's the shortcut. You take 12 and you divide it by root 2 and then you rationalize the denominator, and don't worry, you'll come up with 6 root 2. Well, then to find the area of a rectangle, you need a length and a width. You need a base and a height. So now we need to find the missing side. Now, if this is 60, then I know the complement of 60 is 30. So 6 root 2 is across from 30. I want to know what's across from 60 because that's the side I don't know. So you take what's across from 30 and you multiply it by root 3. So the length times the width, the base times the height. So we get 6 times 6, 36. Square root 6 times square root 2, 12. And then you can factor tree that. That's 2 root 3. 36 times 2. Were you correct, Hussein? Wow, yay Hussein, look at you, very good job. Ask me a question. Did I lose you anywhere? You found the perimeter. I knew that's why you had a plus sign, yeah. Before I move on, any questions about like how I got 6 root 6 or anything like that? We're going to do that one a different day. Here's your homework answers for last night's homework. Today you can title your notes Parallelograms and Triangles. So yesterday we did rectangles and squares, and those were really familiar to you. Parallelograms and triangles should also be pretty familiar to you. The ones that might be a little bit tougher is going to be when we move on to regular polygons and maybe to kite, a little bit of trapezoid. But today should be another pretty basic, middle-of-the-road, easy day. So, how to find the area of a parallelogram. So the cool thing about a parallelogram is that if you draw an altitude of a parallelogram, you can take this chunk right here, you can drag it over, and then you can make a parallelogram into a rectangle without changing the area at all. Now we already know how to find the area of a rectangle. It's length times width, or base times height. So since I can turn a parallelogram right into a rectangle, then that must mean that I can use the same formula as a rectangle. So the formula for the area of a parallelogram is base times height. It's not the side times the side. Be careful, it's not the slanted side. It's the base times the height. So if an altitude is not already drawn, you would have to draw an altitude. Area of a parallelogram, base times height. I showed you 2 pictures because I want you to be aware that the base is not always the bottom. We can obviously rotate that parallelogram and the base could be the side, but you need to choose. You find the length of this and then you need to find a segment perpendicular to it, and that would be your height. So the height doesn't always have to go up and down. Just wanted you to see both ways. So the second one we are doing is triangle, and I bet you already know how to find the area of a triangle. I bet you already know the formula. But let me show you where the formula comes from. So it comes from actually the formula of a parallelogram. Now, if I take this triangle, we want to make it into a shape that we already know how to solve the area for. So what I'm going to do with this triangle is I'm going to double it first. Now, since I doubled it, when we're done, we're going to have to half whatever we do. So I doubled it. We're going to have to undo that in a minute. I doubled it. I'm going to rotate it. I am preserving the area. I haven't changed the area of that triangle when I rotated it. And now what does that look like? What shape is that? A parallelogram. So now I'm finding the area of a parallelogram. Well, we just learned that the area of a parallelogram is base times height. But remember, I doubled that triangle, so we need to undo it, The opposite of doubling is halving. So there's how you derive kind of a derivation of the area of a triangle formula. Now, how else are you going to see this? You're going to see it like this on your formula chart. So be aware that those two are the exact same formulas, and you can use them interchangeably, and you can use whichever one you like better. Whether you like 2 in the denominator or whether you like 1/2 as your coefficient. Same difference. Good, Yeji. Cool. Because y'all just took the Math CVA. Okay. Oops, not doing that. So let's get right into some examples. Find the area and perimeter of the parallelogram. I will call on you. All right, so before we get ourselves ready to do the perimeter, we're going to have to find a missing side. We don't know this missing side right here. We do know that in a parallelogram, opposite sides are congruent, so if that's 8, that's 8. And then looky here, we have a nice, beautiful 3, 4, 5 triangle. 3 squared plus 4 squared is 5 squared. So very good. Our perimeter is 10 plus 16 for a total of 26. 26 centimeters. 1D. Yeji, what'd you get for the area? A new answer, please. There you go. Okay, so the area is base times height. The base is 8, and the height is 4. The height is not 5. Be careful. The height is 4. So 8 times 4, 32, and then you want to make sure your units are squared. Centimeters squared because area is 2D. Okay. Oh, you added 8 and 3. Yeah, this whole side is 8. So this whole side is 8. So this is 3 and 5, but we don't really care about that. Okay. Next one. Find the area of the parallelogram to the nearest tenth. Remember, when we're solving problems like these, we don't round until the very end. Minjung, this is your problem. If you can write the area whenever you're ready. I will write down a formula just for people who are having trouble getting started. So we know that we have to use trig because this is not a special angle. It's not one of our special right triangles. So compared to 35, we've got opposite and we've got hypotenuse. So to find the height of this parallelogram, we would do sine, we put our angle in there, and then we put opposite over hypotenuse. X is in the numerator, so we're going to multiply. 5 times sine 35. That's going to be the height. And we know the area is base times height. Ready, Minjung? Everyone in degree mode on your calculator? Round to the nearest tenth. Okay, yeah. 28.7 centimeters squared. Cool. Moving on. Find the area and perimeter of the parallelogram. Helaman, whenever you're ready with the area. We all know that the perimeter is 10, 20, 8, right? Do we have units? No units. Four is across from the 90. So what's across from the 30? Come on, Helaman, you should have an answer. Should be ready to go. Yes, the area is 20. And we don't have units, so like we said, we're not putting units. Since 4 is across from 90, we know across from 30, it's half of our hypotenuse. You just take it and you cut it in half. This is 2 root 3, but that has nothing to do with the problem, so we don't use that. Area is base times height. 10 times 2 is 20. That's all there was to it. Next one. Tahani, you do the perimeter, and Jenny, you do the area. We're moving on to triangles. Means we're about halfway done with the lesson, right? We're probably more than halfway. Very good, Tahani. 24 for the perimeter. 24 meters. The missing side is 6. Very good. Try that area again, Jenny. So the formula for the area of a triangle is base times height divided by 2. That is the most common mistake that all my students make, is they don't divide by 2. But remember, a triangle is half, well, in this case it's half of a rectangle, but normally it's half of a parallelogram. So you do the formula for parallelogram, but then you have to divide by 2. So 6 times 8 divided by 2, look at that, 24, 24. That's just a coincidence. That doesn't happen every time. Very good. Uh-oh. What's going on here? Find the area. So area only this time. I will give you a hint. That altitude does not cut that side in half. So it's not 6 and 6. Be careful about assumptions. That's not an isosceles triangle. Therefore, that altitude does not cut that 12 in half. Again, you guys did it again. Well, not you guys, just Quan. Hey, what's the formula for the area of a triangle? Base times height divided by 2. This is not a parallelogram. 1/2 base times height. You've got to cut it in half. That's 2 times in a row. All right, so the area is 17.7 squared inches. How did we get that? First, we had to find the height. And to find the height, we did sine of 25 equals opposite over hypotenuse. 7 times sine 25. That's the base. 12 is the height, and then you divide it by 2. Or you could just multiply. Sorry, I got those mixed up. 12 is the base, the other one was the height. You know what I mean. Or you could just take 7 times sine 25 and multiply by 6. Okay, let's keep going. You will see this problem multiple times again, multiple times in the future, so make sure that we feel good about this problem. Find the area of the triangle. I'll let you think for a minute. I wouldn't personally use Pythagorean theorem. I would use 30, 60, 90 triangles, but you can use Pythagorean theorem. So the first thing we need to do is we don't have a height yet. There's no height even drawn in this picture. So we need to draw ourselves a height, an altitude. But there's something unique about this triangle. It's an equilateral triangle. We know the angles of an equilateral triangle are all 60. And when you cut 60 in half, you get 30. So you're welcome to use Pythagorean theorem, 6 squared minus 3 squared. But you're also welcome to use 30, 60, 90 triangles. Austin, when you have the answer, tell me the answer to this problem. Okay, 3 is across from 30, so across from 60 we have 3 root 3. So base times height divided by 2. 6 times 3 is 18. Good job, Austin. 18 divided by 2 is 9. The answer is 9 root 3. And I saw people still not dividing by 2 for the 3rd time in a row. We've got to divide by 2. Not an option. We're going to skip that one for today. Let's do this one. How many more do we have? 2. Okay, I like this one better. Let's do this one, and then I think we've done enough practice. In the squares shown, M, L, K, and J are midpoints. Find the area of the shaded region. So what are you guys thinking? What shape is that shaded region anyways? Okay, so is that shaded region a shape that we know the area of? How to find? Can we find the area of that shaded region? Yeah, it's like a pentagon, 1, 2, 3, 4, 5. Yeah, it's a pentagon. And it's not a regular pentagon, so honestly, there's no formula for that. So who has an idea? Make a triangle out of the shaded region? I have another idea. Ooh, Albert has a guess. What about thinking of it like a subtraction problem. Yeah, I was thinking of find the area of the square, then find the area of the two triangles, and then just subtract. You want to try that? If you want to make a triangle in a parallelogram, you can. You can totally do that. I don't know if you'll be able to find the base and the height of that. Probably you will. So what would be the area of the square? Square minus triangles. So the area of the square, well, that's easy. It's side squared. 1 squared, it's 1. And then I just recommend finding the area of the triangles. So this is 1/2. This is 1/2. So base times height divided by 2. So that'll be one of our triangles. And then this is 1/2 and this is 1. So base times height divided by 2. So there's our other triangle. Y'all already have the answer. So 0.5 times 0.5 divided by 2. That is 0.125. And 0.5 times 1 divided by 2 is obviously 1/4. So 0.25 plus 0.125. 0.375. 1 minus 0.375. What is that as a fraction? Math, enter, enter. Very good. So, just kind of making you think.